So what happens inside a convolution neural network that we'll like to understand? Okay, it is basically an image, okay, where you have kernels, okay, few layers of convolution, and then there is a flattening, and then same thing, guys, same thing, but I've given you an input image. This is the input image. It goes. A decoder actually tries to decode, okay, using this information that in another language. So transformers are mostly used in machine translation. Now comes to the first part, that is your convolution neural network. So what happens inside a convolution neural network that we'll like to understand? Okay, it is basically an image, okay, where you have kernels, okay. So you kernels are basically these. Suppose you have an image of a zebra over here. Kernels are small rectangular box like this, okay, which are placed in image, and it slides over the throughout the image. Like it is placed over here, then it slides here, then it's at each step it slides one by one. It slides like this, it slides like this throughout the entire image. It slides, okay. It slides and then it goes ahead. It slides, it goes ahead. It slides, it goes ahead. Once it slides, it creates, it has a formula through which it creates certain values, okay. And this thing which I explained, that this sliding, this is known as convolving, okay. Image on an image, there is a kernel which convolves in the image, okay, and it creates certain values layer by layer, okay. There are three layers over here, RGB, okay. There are three layers. Same way, there is another convolution that happens, convolving, that happens. Again a kernel is applied, and there is another image, another calculation is created, and the layers also increases like this, okay. And again there is keep on happening till a level, it is till a level where the image data becomes very matrix level small, where the image data becomes very small, and you can do your model development over it, or you can create your prediction over it. So first you have an image, it convolves, okay. The images are nothing, it is just values. Just remember one thing: if you are seeing top corner over here, okay, top corner over here, it is some value, maybe 0.02, okay. Maybe this is 0.05, this is 0 point, this might be 255, something like that. This image will be convolved, and the values will be transferred over here. And this image over here, whatever you are seeing, the second one, the convolution after the zebra one, this will also have values which will also look like somewhat like zebra. Over here they have made it brown, but this will also look like something like zebra only, but it will be very hazy. After that it will go, and this will look like something, a mix of zebra or a horse, okay. Example I'm giving you, okay, very weird example, but you get the point, okay. After this, probably you will not be able to understand the image at all. This will be understandable only by computers. So it has done all the calculations, and it has come to a point where the values are represented by only numbers, okay. It only has numbers, okay. Your zebra has become this now. Again one more layer, and then your zebra is converted to a, this thing is known as flattening, okay. Your image becomes a flattened layer, okay. In flattened layer you have values, everything on one, just a one column, okay. Over here you had columns and rows and columns, it was like a matrix. Now it has become a single column value, okay. It has values only. And then after this, okay, you can create a plain deep learning, which you have learned over here, deep multi-layer perceptron, which is, this is the part what I'm talking about. This is known as a deep multi-layer, where each data is connected to each other. See, each, remember, this is this only, like you can directly connect to this only, but they have created another bridge in between, okay. Each layer is connected to each other. This is known as fully connected layer. And then you get the output, whether it's a horse, zebra, or something. You get a probability, 0.2 of a probability of horse, 0.7 of a zebra, 0.1 of a dog. So highest is zebra, that is why we go for zebra, okay. Guys, did you understand at some basic what is happening over here in the convolution neural network? Can you give a done at least in the chat box if you have understood to some level? Okay. So what happens is, image, convolution layers. Okay, there is kernels are nothing, it are small, like this image only, that is also another type of matrix which has some value in it. So it will have maybe 3241 5621 213, like that. Okay, this is one kernel, and that will continuously convolve over here. Okay, and that is how this will come. Then another kernel will be here, and that will these yellows are kernel, this will continuously convolve and this will come. Okay, like this will continue, and then there will be a flatten, there will be a deep layer multi-layer perceptron level. There is where the deep learning part is. Okay, so basically convolution is convolution plus this becomes a convolution neural network. Okay, and then it predicts. Okay, and this softmax is nothing but a activation function. Okay, which actually tells which one to fire, this one to fire, or this one to fire, or this one to fire. Okay, at what probability it should be fired. This one should be 0.2, this one should be 0.7, 0.7. So these are all calculations, guys. You all might be confused, like, what is this, what are these values? These came throughout calculation. Okay, and that requires you to go through a certain kind of development, and in order to understand these calculations and formulas, in order to that's where LearnTube comes into play. And that is what you have to understand through a course, basically. So this is the same thing which I told you. First, it goes through a few layers of convolution, and then there is a flattening, and then same thing, guys, same thing. But I've given you an input image. This is the input image. It goes through convolution layer, okay, and then there is a fully connected layer. This is also known as dense layer, because this is each of them are these are densely connected, okay, and this is the output layer. Now this is with respect to convolution neural network. Now comes to recurrent neural network. Okay, in recurrent neural network, guys, the things changes. I'll give you in recurrent neural network. This is where your language. When I'm speaking something, speech to text. Alexa is the biggest example of recurrent neural network. Okay, so recurrent neural network does what? It actually takes an input. Suppose I want to convert. Okay, it was an awesome movie. I want to convert into Hindi. बहुत अच्छा मूवी था. ठीक है. तो first what it will do, it will convert, it will take each of the words is converted to a numbers. First of all, first it is converted to a number. Okay, and those numbers are feeded into this kind of architecture. Okay, in this kind of architecture, what happens is basically each layer will pass some information into the next one. See the first layer, that is, it is having this is passing something to this, then was is passing something to this, then Anne is passing something to this, and then awesome is passing something to movie. Okay, this is what the middle, this transformation does. Okay, this actually transform a data, a state. Okay, that what has happened historically. That is why my next sentence will depend on the previous sentence, previous words. My next word will depend on the previous word. This happens because I am able to do it in my brain. In a computer, in a neural network, this is how it happens. Okay, so first word is a pronoun, next one is a verb. Okay, these understanding are also retained by this state. Okay, that what is to be used as a next word, and this is also used, and the input is also used. So there, you can see there are two types of input. One is the word itself, and one is the word to the next word. Okay, so this has two inputs. One is the word, and one is the previous word. Okay, and this is how it actually uses previous sentence to predict the next one. Okay, so where neural network is used, it is used to predict what will be the price of the stock market, what a person, fill in the blanks. Suppose you have a huge sentence, you want to fill in the blanks. Okay, that is where, because each word has some meaning, and that is how you write it. Okay, so recurrent neural network has one advanced thing which is currently trending, which is known as transformers. Okay, transformers is nothing, it is just it actually it is an encoder decoder model. What is encoder? It first takes this entire thing. Okay, and it takes, you can see this it was an awesome movie. Same thing is happening over here. There was output, there was output that was given over here. There is no output over here. Okay, we are not taking output because we are interested in something else. So first over here it gives I love you. Okay, it takes an encoder, gives some encoding. Okay, it retains the information. Okay, it has some information retained in it. Okay, encoded in some form of machine language. Okay, and then a decoder actually tries to decode okay, using this information that in another language. So transformers are mostly used in machine translation, okay, language to language models, okay, sequence to sequence model. You have a sequence, you want to convert into another sequence. So that is where a transformers is used, and transformers is has done a biggest breakthrough in the world of RNN or AI. Okay, in terms of like, there is a wing which is known as, uh, there is a open AI research company which develops something which has developed something known as GPT, okay, which actually uses transformer. GPT is nothing, it's a transformer. It can actually predict or write words, okay, write words. If you ask any question, it can give you answer. If you wanted to write a code, it will give you code as well, okay. So usage of AI in our daily life is voice assistant, image recognition for face unlock. This is used in many, in your phones and all. Personalized marketing, okay, and ML based financial fraud detection and credit card fraud detection. Many times, if your location is not right, suppose you were in Bangalore in the morning, and all of a sudden you are in, somewhere in, probably in Baku, Azerbaijan, okay, and they probably your credit card, you have an international payment, still your payment could be, default, because all of a sudden the location changed, okay. So such, due to carding, maybe somebody stole your card data and it is being used from there. So in order to understand this, that is where, financial fraud detection, that is where, AI is being used at this moment. Okay, so guys, did you all understand the applied AI part? I'll be going to the next part as well till now. If you all have understood, if you have got an idea about the applied AI part, the CNN, RNN, then I can go ahead and, show you something interesting. Okay, so guys, I'll share something known as, something known as which this which will, this is the entire thing, which is Chat GPT. I think this is very much trending. What happens? What? How powerful is Chat GPT? This is OpenAI's GPT 3 point. Some people are saying it is 3.5, but it is part of 3 series. Okay, so GPT started from GPT 1, 2, and now it is into GPT 3. And this was developed till 2021. Like after data of 2021, it cannot process. Okay. It was trained on billions of data, okay, billions of sentences, and it is very powerful. If you ask it to do anything, it will give you a lot of answers. Okay. So suppose if you ask it to do, suppose if I write, see, I have written, give me a code to develop a landing page. Okay, see, it will start writing its landing page also. It will start writing your code also. Okay. So this is what chat gpt is. It is so powerful. It can write you marketing lines. It can write you, copywriting mind. You know what is copywriting? If you the ads you see on Facebook, the things that you see, the description that you see, or the videos that you see on YouTube, the description that you see, okay, that is what copywriting is. Okay. So it can create any marketing template content. Okay. If you wanted to write it to, essay, suppose essay on AI. See, it is literally writing a landing page, basic landing page. Okay, this code will create a simple landing page with a hero section that has a large heading. It is even telling you what it will do, and a call to action button also. Okay, if you want, it can write a essay for you, and if you want it to change, see, it starts writing essay for you. Okay, I just wrote essay on AI. Okay, you can go to ChatGPT, just search ChatGPT on Google, sign up with your email ID, and you can start exploring it. Okay, it has a lot of limits. It cannot, if you just ask it to write, how to, how if you want to write something violent to it, obviously it will not give you that answer. Okay, it has some limits that has been forcefully being that is being set up by them, so that it doesn't create such unnecessary things, situations. Okay, so if you want it to change it for so and it has a sequence understanding also. Suppose I wrote a essay on uh, uh, make it relevant for a LinkedIn post. See, I first I asked it to write an essay on AI. It wrote a essay. Now I wrote make it relevant for a LinkedIn post, and it started writing the same thing. Okay, it even remembers the old thing as well, and it started writing the same thing, that it started revising the whole version so that I can post it on LinkedIn as well. Okay, so this is what ChatGPT is all about. Next thing, guys, are you understanding? Is it exciting? Like, do you feel it's an amazing thing or amazing, technology that has been, cracked by, OpenAI? So guys, so you can see this is just GPT 3, and GPT 4 is to be it is expected to come. GPT 4 is expected to come in next 2 years probably, and GPT 4 is expected to be trained on 100 trillion rows of data. Okay, so and this is just around probably around 100 billion. So GPT 4 is expected to be way more powerful than this, and you can imagine what kind of job it is going to replace. And if you are in the frontiers of this disruption that is happening, just imagine that you are probably the safest person that you will be in next 5 years in terms of the job that you will have. Okay, from this field. So that is where a lot of jobs is going to be done. Even now GPT 3 is going to write pretty much basic website it can design. Okay, it can imagine what GPT 4 can do. GPT 4, like, you just imagine iPhone when it was started in 2007, and where is iPhone now. Okay, so just imagine after 5 years or 6 years where GPT will be. Okay, and this is just 7 years of development from GPT 0 to GPT 3. Okay, GPT 3 suppose 2021 20. Okay, where GPT 3 has been started using. Okay, this is just that much type of development. Okay, so you just imagine in next 2 3 years more data will be generated, and the exponential the way the data is being the way the model is will be developed, it will be more quicker. Okay, now guys, I'll also show you something known as Dolly. Okay, uh, okay, I will just sign up, guys. Guys, like you have seen for GPT, there's something known as Dolly also. Okay, if you want, you can just write. Okay, an astronaut roaming in a desert. Will literally create images of an astronaut roaming in a desert. Okay, somewhat it will try to create. See, it will try to create. Okay, in painting style. It will try to give. Okay, so this is in painting style. Okay, if you give something else, it will give something else as well. So this is, guys, this is all done through prediction. This is all done through your deep learning. This is where deep learning has gone to a level. Okay, it is able to literally give your style. See, I have given just astronaut roaming in Mars in painting style. It will give you images like this. You can even go and edit your images as well.